Captain Peter Cutsey, another of my online self-briefings. Today, engine fire after V1. We're sitting in Kabul, Afghanistan. We're on the threshold of runway 29, as you can see from the aircraft. And a look at the JEPI chart. Here it is here, and that's us here on the threshold of runway 29. A high altitude airport at 5,877 feet MSL. And terrain quite a factor. Here's a 2D version of the runway from Google Earth, and we'll go from a 2D to a 3D to give you an idea of the terrain in the area. We'll be taking off on runway 29, experience an engine fire right after V1. All right, so let's get right into a briefing. The objective is to recognize an engine fire and take the appropriate actions. The glare shield in front of the captain, in front of the first officer. Fire warning lights, master caution lights, and down on the fire panel, which is out of our field of view, the engine 1 fire switch illuminated and the engine 1 overheat. So that is how we can recognize. There will be a fire bell also, which we've heard already. The appropriate actions, the pilot fly the airplane. The pilot monitoring will cancel the bell and warning light. And when the airplane is under control and the gear has been retracted and at a safe altitude has been attained, a minimum of 400 feet above field elevation, accomplish the recall items, which there are for this particular non-normal. Aviate is first. Navigate is second. Communicate is third. You fly the airplane, and in this case, there will be a special engine out procedure, which we will discuss later. We have to get involved in flying that. That's a navigation portion. And somewhere shortly after pilot monitoring on the pilot flying's request, contact the controlling agency. In this case, it will be Gibraltar. Once we have navigated to our holding point, which will be over the Kabul VOR today, then checklists are to be completed. And this is the order. The first item is the engine fire checklist, or checklist engine fire, or engine severe damage, or separation. You would call for it that way. Then, once that is completed, the after takeoff procedure, which is memorized by the pilot monitoring, then the after takeoff checklist, then any other non-normal checklist, and is depending on what your decision was, in today's case, to return and land because the weather is appropriate. The last non-normal will be the one engine inoperative landing checklist. Let's have a look at an overview. This will open the screen. The field elevation to 400 feet, 400 feet to 800 feet. This is above field elevation. And then 800 feet to MSA. All right. 2 engines operating, fly the airplane, track the runway center line. speed V2 plus 15 to V2 plus 25. Remember, both engines are operating. This would be unlike a severe damage or a separation or almost all other engine malfunctions where you lose a certain amount of power on one engine at V1, which would be considered to be flying on one engine. We'll talk about that in future videos. All right, so follow the command bars. And the pilot monitoring would cancel the fire bell by pushing one of the master fire warnings and cancel the master caution in case there's another problem. All right, so at 400 feet, heading select, and then grayed out, but it's going to apply probably for today. Actually, it won't apply today, but it could apply depending on the situation. Today, our bank limit will be greater than 15 degrees. We'll talk about that when we look at the engine out procedure. In any case, if you notice in bold, I've got heading select and then identify the malfunction and perform recall items as required by the QRH. That's basically what you do at 400 feet, 2 items. The others will be dependent upon your SOPs and company procedures that you have. So, recall items to be completed. There are recall items to be completed today. At 800 feet, confirm VNAV path and speed bug moves to flaps up speed. Or if that doesn't happen, level change and set flaps up speed and clean up. Once reaching the minimum sector altitude, and after flaps are up and lights out, set max continuous thrust, set VNAV, or if not in VNAV, level change, and return the bank selector to auto as required. Because later on when you're on vectors, if you haven't returned the bank selector to auto or whatever your SOPs state, perhaps 25 or 30, you will not be able to perform a proper vector if your bank limit was, say, let's say at 15 degrees. All right, that's something that's not written, and that's airmanship, and that's why I'm mentioning it here. Now, if returning, set the best holding speed, and if continuing en route, select the engine out from the FMC CDU and climb at engine out speed to the engine out altitude that you requested from ATC. And follow your company SOPs. All right. I've got a little note down here that we're going to see later on. If you had a malfunction other than an engine fire, you would fly the airplane, use rudder to center the control wheel and track the center line and your speed V2 to V2 plus 20, and that should be commanded by the command bars once you've pitched up to 12.5 degrees, according to the FCTM. All right, let's go back to the main menu. And now that we've looked at that, let's have a look at each segment one by one. The first segment that we were talking about was from liftoff to a minimum of 400 feet. Now, in this particular case, fly the airplane, yes. Cancel the fire bell or master caution as applicable. That will be the pilot monitoring's duty. So in this case, both the master warning and master caution should be canceled. Now, what we have here, the next item, the third and the fourth, would be for an engine inoperative. So make sure that in today's case, it's a normal rotation to 15 degrees, then follow the command bars after. All right, so follow the command bars. Remember, we're 2 engines today for this particular point. Track the extended center line of the runway. You can do that in heading south and use rudder trim when under control. Well, that would be if you had an engine out. And then engage in autopilot when trimmed and comfortable. I say that, minimum of 400 feet, of course, but I say that because it's most important that you fly the airplane and you have full control of the airplane before you engage in autopilot. The aircraft is not in trim, an autopilot won't be engaged. So if you rush the process, you'll end up probably not flying the airplane properly. So a big consideration. So remember that what we're looking at here applies to an engine and operative. In this case, we have two engines operating, so fly the airplane, cancel, and then rotate at the normal rate, follow the command bars, track the extended center line, and then later on, we'll talk more about this. And that will happen after that we start doing the memory items. Okay, once you feel comfortable, if the problem is engine number 1, engage autopilot B. That will save electrical transfer problems when we go to the APU later. And then engine number 2, malfunction, engage autopilot A. I've graded those out. That is a technique, and you follow your company SOPs. All right. From 800 feet above sea level to MSA, fly the aircraft and track the extended center line. Now, at this point, you're going to be on a single engine because you will have done the memory items that we'll cover later in a PowerPoint. So at this point, you are flying with an engine out. So track the extended center line of the runway, and we'll show you a little picture on how to do that later. Ensure VNAV path enunciated on the PFD and speed bug. Moved to flaps up speed. If it doesn't happen, you're going to have to select, open the speed window and bug up and then clean up. You track flaps on schedule, flaps up, lights out, VNAV or level change as per your company SOPs, and CDU N1 page, and select con thrust, MCT. All right, so that is what we do from 800 feet to MSA, and then from MSA and above, which is the blue zone, we're going to navigate. You may have to turn before that. In today's case, that will be the case, but this is just something general. Providing you're at MSA and above, you're not restricted in most cases to any bank limit. So communicate your intentions, ensure the bank limit is returned to auto, as I mentioned before. If returning, ideally hold over the departure airport. We're going to be doing that today. And set up the holding and a quick review to ensure recall items are completed. Now, as you are aviating, and we're going to be in a left turn after takeoff using, I believe it's 20 degrees of bank, we'll check it later, and turning left all the way around back to the VOR, which is very close to the center line, extended center line of runway 1. You are going to, maybe somebody should mention, have we completed memory items? Yes, we have. All right, fine and dandy. Just make sure that, because things get pretty busy and it's easy to forget if there are memory items involved. So then enter the hold and then complete the first non-normal checklist, which is the checklist engine fire or engine severe damage or separation. And that's how you call for it. After you've completed that checklist, complete the after takeoff procedure and then the after takeoff checklist. And then complete any other non-normal checklists. Complete one engine and operative landing checklist down to the deferred items. This will be the last checklist, the one engine and operative checklist. But the reason I say that is you may be heading en route and you may not want to do that one engine and operative landing checklist immediately if you're going en route to another airport. But if you're coming back and landing, which will be the case today, we will do the one engine and operative landing checklist as the last checklist, down to deferred items. And then we'll get the airplane ready and the approach and set up. And then we'll continue with the checklist, which will cover the descent approach checklists. And that's all included in the one engine and operative landing checklist. So that's what we've mentioned here. All right, so that is important. So let's just have a quick look at PowerPoint. Remember that pilot flying, fly the airplane, rotate normally because you're on two engines, 2 to 3 degrees per second towards 15 degrees of pitch, and follow the command bars. The pilot monitoring, in this case, it will be the first officer, cancel the fire bell, and of course, master caution, if it is illuminated, which it probably will be, cancel it also, in order to allow it to pick up another problem. Now, verify a positive rate climb on the barrel altimeter and call positive rate. So the barometric altimeter will be the last one to move. Don't use the radio altimeter and don't use vertical speed. Make sure you get your barometric altimeter moving. It's the last one to move. Then call positive rate. And the pilot flying, after checking the positive rate on the barrel altimeter, will call gear up. Pilot monitoring, place the landing gear lever to the up position, and when the gear lights are extinguished, place the landing gear lever to the off position. That's on the NG. On the MAX, the landing gear lever will remain up, the position. Track the extended center line on the nav display. Here's just a quick look at what our nav display will look like today. So track the extended center line. And this is the engine out procedure at 5.8 DMA of the Kabul VOR, which is very close to the airport. You're going to start a left turn at 20 degrees of bank back to the VOR, then hold inbound 110 degrees right-hand turn. All right. This isn't Kabul, but it's just a sample that I'm using for tracking the extended center line. If you notice, the wind is quite strong and 90 degrees to the runway. And of course, our heading will be off to the right if we're tracking. Use the 30-second trend vector and put it on the white dotted line, which is the extended center line of the runway out to 14.2 nautical miles. If you put the tip of the 30-second trend vector on the white dotted line, you will return to the actual track. In this case, for this airport, it was a track of 120 degrees or 119. And that's how you track the center line using your nav display. This tool is super duper for tracking the center line. You don't have to even think about the wind as long as you use that trend vector. All right, so that's good. At 400 feet, call heading cell and ensure VNAV is engaged if equipped. And if required, set the bank limit. In our case today is 20 degrees and open the speed window and identify. The pilot monitoring will select heading cell unless we're already there. Ensure VNAV is engaged if equipped. And if requested, select the bank limit, which today will be 20 degrees, and opening the speed window. Identify the malfunction and call engine fire number 1. Now, pilot monitoring also makes sure that you select recall at 400 feet. That'll bring the master caution light back, which it has been triggered by the overheat light. So that's important. So, and that's not done till 400 feet. So disengage the auto throttle, and with the hand on number 1 thrust lever in this case, the pilot flying, in this case is the captain, will say engine number 1 thrust lever, confirm. and the pilot monitoring looking will make sure that confirming engine number one, and we'll say confirm number one, and the pilot flying will retard the number one thrust lever until the lever is closed. And the pilot monitoring, first officer in this case, will make sure that he does that. All right, that's important. And then the pilot monitoring places his or her hand on the number one engine start lever and says, engine number one start lever. The pilot flying confirms the selection is correct and says, confirm number one. Pilot monitoring selects the respective start lever to cut off, saying cut off. Your company SOPs may want you to say something different, but this is standard that most airlines use, and this is what Boeing recommends. Pilot monitoring places his or her hand on number one engine fire switch and says, engine number one fire switch. Pilot flying confirms and says, confirm number one. A little note I put here, ensure to place the hand under the fire switch in order to allow the pilot flying to view the switch before pulling. All right. Pilot monitoring pulls the respective fire switch and says pull. If the engine fire switch lights, or, very important, or the overheat light is illuminated, engine fire switch rotate to stop, hold for 1 second. After 30 seconds, the engine fire switch overheat light stays illuminated, engine fire switch rotate to the other stop and hold for 1 second. Keep the pilot flying informed of the status of the lights. So that is up to that point is what we're going to cover now. And let's just go and have a look at it. Right, let's just have a look at the actual pictures that we just talked about. Thrust lever number one, close. After confirming it, and just start lever number one, cut off after confirmation. And if you notice, the hand is under the fire switch. If you put your hand over the fire switch, you won't be able to see the fire switch lights. So that's important. And if the engine fire switch, warning switch, or is important because you may not have these lights on, but you may have the engine overheat light. Then you rotate and hold for 1 second. All right. And if after 30 seconds the engine fire switch or engine overheat light stays illuminated, then rotate to the other stop and hold for 1 second. Okay. Continue to monitor the status of the engine fire. So this is just a review. This will terminate the end of this video, which will be part one. And in part two, we'll get into a few more items, and then we'll go on to flying the airplane and experience an engine out. Thanks for watching. See you in part two.